Hey, Math Journey! Today, we have an exciting challenge for you, solving a tricky equation with a cube root and a cubic polynomial. Are you curious about hidden patterns? Stay tuned because we're about to dive into it. Let's get started. Here's the problem we're going to solve today. We need to find the value of x in this equation. Cube root of 3x squared plus 3x plus 1 equals 8x cubed minus 3x squared minus x minus 1. And we need to express x in the form x equal cube root of a plus cube root of b plus 1 divided by c, where a, b, and c are natural numbers. Our goal is to find the sum of a plus b plus c. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. To solve this equation, let's start by defining m as m equals the cube root of 3x squared plus 3x plus 1. Cubing both sides gives us 3x squared plus 3x plus 1 equals m cubed. According to right side of original equation, we will arrange this equation to have minus 3 squared minus 1 in one side. Now, by substituting m back into the original equation we have m equals 8x cubed minus x plus 3x minus m cubed. If we rearrange it, we get m cubed minus 8x cubed plus m minus 2x equals 0. By looking at this equation, we can easily rewrite 8x cubed as 2x cubed. We know from the difference of cubes identity that a cubed minus b cubed equals a minus b times a squared plus 2ab plus b squared. So from refactoring of m cubed minus 2x cubed, we have m minus 2x times m squared plus 2xm plus 4x squared plus m minus 2x equals 0. If we rewrite 4x squared as 3x squared plus x squared, the equation can be simplified using the square of a binomial identity as this. Now, by factoring of m minus 2x, we have, since product of two expressions is 0, either first one or second one has to be 0. It is clear that second one is always positive, therefore first one, which is m minus 2x, must be equal 0. Then, m equals 2x. Now by substituting m back into the original equation, we get 2x equals the cube root of 3x squared plus 3x plus 1. Let's cube both sides. 8x cubed equals 3x squared plus 3x plus 1. To have a simpler equation, we can add x cubed to both sides. Then, by recognizing this as a cubic polynomial, we can rewrite it to be 9x cubed equals x plus 1 cubed. So, it will be solved as x plus 1 equals the cube root of 9 times x. Finally, x equals 1 divided by the cube root of 9 minus 1. If we rationalize, we will have x equals the cube root of 81 plus the cube root of 9 plus 1 divided by 8. Therefore, x equals the cube root of 81 plus the cube root of 9 plus 1 divided by 8. By comparing this result by problem requirement, we see that a equals 81, b equals 9, and c equals 8. And finally, adding them gives a plus b plus c equals 81 plus 9 plus 8 equals 98. We've cracked the problem and figured out that a plus b plus c equals 98. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.